For our math warm-up today, I'd like you to number your boards or papers from 1 to 4 and use the estimation method to multiply these decimals to figure out where the decimal point will go in these 4 problems. So go ahead and pause your video and complete that now. Okay, our first problem would end up with our decimal point here between the 7 and the 0. So we would have 17 and 8/100ths. Problem number 2, we would have our decimal point between this 3 and this 5. So we would have 53 and 58/100ths. The third problem, our decimal point would go between the 8 and the 1. So we'd have 308 and 10/100ths. And last but not least, our decimal point would go between the 2 and the 5 for this problem, 742 and 5/10ths. How did you do? For our math message today, you are going to need to get your math journal and open up to page 250. So if you'd like to go ahead and pause your video, grab your materials, and come on back. So you'll notice with our math message today, they are asking you to take a look at several quadrilaterals that we have here on the left, A through P. And it tells us that we need to work with a partner, read all the definitions below, find one quadrilateral card that shows an example of each type of quadrilateral, and then write the number or letter, of your example next to the definition. So what we're going to be looking for is trapezoid, kite, parallelogram, rhombus, rectangle, and square. So I'm going to have you go ahead and complete this with a partner in class and thinking about when we did the hierarchy of triangles with the last lesson, what that looked like. Because we're going to take that information to help us in this lesson later on. So again, you're going to take a look at the quadrilaterals here on this left side, and you're going to write one letter for each definition here on the right. So you may need to pause your video so you can take a good look at those quadrilaterals. Work with a partner to complete this section. Once you have completed this math message in your workbook, you may come on back and check your work with the answers that I have shared. And once again, here are those answers so that you can check your work. So a trapezoid is a quadrilateral that has at least one pair of parallel sides. So if we look at letter D, this side and this side are parallel to one another. These two sides are not, because they eventually do cross and intersect. K for a kite. How fitting, right? Because it starts with kite, K. But anyway, a kite is a quadrilateral with two separate pairs of adjacent equal length sides. So adjacent means that they're across from one another. So we can see that. And then a parallelogram is a trapezoid with two pairs of parallel sides. So if we look at letter G, we have a parallelogram. This side and this side are parallel. This side and this side are parallel. A rhombus is a parallelogram with all 4 sides equal in length. If we look at letter A, all 4 of those sides are equal in length. A rectangle is a parallelogram with 4 right angles. So again, we're looking for a picture that has 4 right angles, which this one meets that criteria, but so does this one. A square is a rectangle with all 4 sides equal in length, which here is letter L. All 4 sides are equal in length, but they also happen to have right angles. So when we start to think about our last lesson, we had the hierarchy and we talked about overlapping traits. So again, we're going to be looking at those overlapping traits with quadrilaterals. Today's lesson is a hierarchy of quadrilaterals. The reason we are doing this lesson is because, once again, we need to be able to reason abstractly and demonstrate thinking using diagrams and pictures. Look for attributes or patterns, and we're going to do that by exploring a new way to classify quadrilaterals into a hierarchy. So let's take a look at what's to come. So this math message you should have already completed. At the bottom of your math message page, you have some questions that talk about hierarchies, and we're referring back to page 251. So for example, it says, from the hierarchy, you can tell that all trapezoids are quadrilaterals, but not all quadrilaterals are trapezoids. Use the hierarchy to write two other statements like this. All blank are blank, but not all blank are blank. So you're going to complete that. You're also going to look at the relationship with that hierarchy, answer some questions here, using that hierarchy to kind of help you complete the statements. And then we get into the meat of the lesson here with the hierarchy itself. Notice we're starting at the top with quadrilaterals. They have a section here that says test property. So you're going to put what property that you're testing for that particular item, and then determining whether it's going to go to the trapezoid test next, or does it fall into the category for kites. And so you're going to kind of follow this hierarchy, whichever direction that you deem feasible for that particular shape. You may have noticed that this hierarchy is quite different from the one that we previously did with triangles. It's a bit more complicated, and we have what is called branched hierarchy, and that is when we have a category that has more than one subcategory. So for example, quadrilaterals has two subcategories, right? It has trapezoids and it has kites. So you can see that this one is just a little bit more complicated and is going to require a little bit more thought. So let's take a look at the quadrilateral hierarchy poster that I have here on this left side. And you'll notice that we have the main category up here as quadrilaterals. They give us the properties or the attributes of the quadrilateral itself, so 4 sides and 4 angles. And then we can veer off depending on what the attributes are of the shape to trapezoid or kite. So if it's a trapezoid, all of the properties it has would include the properties of the quadrilateral itself, plus at least one pair of parallel sides. If we put it into the kite category, it's going to have all of the properties of the quadrilateral, plus 2 pairs of adjacent equal length sides, right? The sides that are next to one another that are equal length. And then we follow through. So if we're in the kites area, we're going to jump down to rhombuses, and we're going to look at the characteristics or properties of a rhombus. If we're in the trapezoid section and we've got a shape here, we're going to test it for parallelogram next. Again, read the definition for parallelogram and determine, are we going to go rectangle route or are we going to go rhombus route? And again, you're going to take a look at each of the definitions to determine the path that your shape is going to have. It may end up staying in one particular category. It might also have dual categories. So it might have both things in common where you could decide which route it's going to take. So it could be either. So you might have a situation like that as well. So again, taking close attention and paying close attention to those definitions for each of those quadrilateral shapes. So let's take a look at how we might go about that. So let's say that we have this shape right here, shape D. Well, is it a quadrilateral? I'm going to take a look here. Does it have 4 sides? Does it have 4 angles? Why, yes, it does. So it is a quadrilateral. Then I have to decide, is it a trapezoid or is it a kite? So if it's a trapezoid, all the properties of the quadrilateral, of course, we already deemed that. Does it have at least one pair of parallel sides? Yes, it does. This side is parallel to this side. So we would move that to the trapezoid category. Does it fit with kites? Has all the properties of quadrilaterals plus 2 pairs of adjacent equal length sides? And I would say no to that question. So for this particular shape, it would fall in the trapezoid category. Then we would move to the parallelogram definition and see if we're going to move it any more. So for it to be parallelogram, all the properties of the trapezoids plus 2 pairs of parallel sides. Well, guess what? This particular shape is going to stay put in the trapezoid section. It does not have what a parallelogram has. So we would leave it here with the trapezoids. I'm going to put that one aside. So let's take a look at another one. We're going to start back up at the top with our quadrilaterals. 4 sides, 4 angles. Yes, it is a quadrilateral. Then we look at the trapezoid. We're going to at least 1 pair of parallel sides here and here, but it also has this side and this side are also parallel, so it actually has 2 sets of parallel sides. If we look at the kite definition, 2 pairs of adjacent equal length sides. So adjacent means they're next to each other or across from each other, right? Those look like they're equal, and they are the same length. So we could put it in the kite category. So you have to decide which route you're going to take. So if we put it in the kite category, then we're going to look down at the rhombus. Has all the properties of kites and parallelogram plus 4 equal length sides. Well, it does not meet that. These are not 4 equal length sides. Does it meet parallelogram? Yes, but we did not go that route. So if we had deemed it a trapezoid, then we would have been able to move it down to parallelogram. And then we could move down this route and say, oh, wait, is it a rectangle? All the properties of parallelogram plus 4 right angles. Oh, yes, it would be down here. And then we're going to take a look at, well, is it a square? All of the properties of a rectangle plus 4 equal length sides. Ah, there's the hang up. So it would not be a square. It would stop in the rectangle section. So take a look at another one here. So we've got our 4 sides. So we know it's a quadrilateral. It's got 4 angles. So again, we have to decide which route we're going to take. And just looking at the shape and looking at the hashtags that we have there, I'm going to guess that it's going to be a kite. So we've got the characteristics of the quadrilateral plus 2 pairs of adjacent equal length sides. So adjacent next to each other, equal length. See, 2, 2, and these 2 are equal. So this would be a kite. Then we're going to look to see, okay, does it qualify as a rhombus? All of the properties of the kites and parallelograms plus 4 equal length sides. Well, no, it's not going to be a rhombus. So that one will live here in the kite section in our hierarchy. And we'll do one more. So once again, we have 4 sides, 4 angles. So we start with the quadrilateral, and then we have to decide, are we going to go the trapezoid route or the kite route? Well, the fact that we have the little tags here, that means that all of these sides are equal length to one another. So do we have parallel sides? This side is parallel to this side. So yes, there's at least one parallel sides, but we also have this side and this side are also parallel to one another. So this says two pairs of adjacent equal length sides. Well, it does have that. So we could also put it in the kite section. So again, you're going to have to make that choice which route you're going to go and then go from there. So if we put it in the kite route, we're going to move down to rhombus. We're going to look at all of the properties of kites and parallelograms plus 4 equal side lengths. Oh, well, it would fit in the rhombus section. Would it fit in the square section? 4 right angles. Nope. So this one would live here in the rhombus section. So let's summarize our lesson today. Working with a hierarchy requires starting at the top and testing each quadrilateral to see if it moves to the next property. Quadrilaterals could pass one property and not another. Some quadrilaterals will not go down either branch, while others may qualify for one or both. You got it? Good. See you in class.